So this is the second workshop. How about we do a warm-up to get to know each other? And for dynamics, it's okay if it's like a short answer and we are talking, you unmute and say something. Use the chat with Ron. Again, for those of you, let me show you how chat today in Zoom looks. It's a new version. So you will have a chat where you can chat with everybody. That's just a picture of it. But to start a chat to someone, to Ron or to me, I won't be always looking in the chat because I'm focusing on switching the slides and looking what we do next. But you open this plus button and then you have a list of who you can add and who you want to chat. So if we're chatting answers to a problem, don't put it in the main chat so people don't see your answer. Just go to Ron's chat, RM, Ron McGarlis, or it probably will show you just Ron. And that's it. Let's go and do a warm-up. So this warm-up is, we call it a coffee break math problem. Oh, I ruined how you see the problems. Here we go. Okay, what do you guys think? It's an equation in disguise. It's a riddle as well. Take a minute to think and chat us your answers. And maybe we can discuss later how to solve this because it's a good math problem, not just a warm-up. And you can start showing thumbs up or unless you put an answer as well. If you're done and ready to discuss this, you might need a piece of paper for this problem to think about. And Ron, feel free to plug in and give us clues, or if somebody wants to give us a clue, feel free to say something if you want. Just don't give us full answers on the screen. Janusz, is this a clue? Do you want to say what you're thinking about?
Yeah, so like the big one is 2 times the small coffee cup things.
The big one looks like it's twice as much as the small coffee cup. How are you seeing this? Explain a little more.
I forgot to unmute.
Yeah. So how are you seeing this? It's a nice observation. Really.
So like two of these, it's one of this must equal 2 of these because there's 2 of these and one of the small ones, and that equals 3 of these and one of the big ones. So we know that the one of like these
Wait,
things
don't solve the whole thing. But do you guys
2 of these.
do you guys see? I think I got what you're seeing. I didn't see it in this way. I was gonna solve it with equations. So I see 60, and this 60 includes 2 big.
Yeah, I found this out with like equations, and then I'm like, oh wait, why didn't I do it this way? It's much easier.
Yeah, do you guys see that I can just replace these 2 cups with this big coffee maker? And then I get 60 again, like in this picture, right? So the coffee maker is same as 2 big cups. Okay, now let's figure it out. So any cup, any 2 cups can be replaced with a coffee maker. And then 1 cup can be replaced with, or what would you rather replace, the cups with a coffee maker or a coffee maker with the cups? So 1 coffee maker is 2 cups. What? Yes, Benjamin, what would you replace? The coffee maker with the cups or cups with the coffee maker?
Only replace the coffee maker with the cups because then we don't have to have like 1.5 coffee maker. 'Cause that
Yes,
would be
we don't have to have half coffee maker. We can have 2 full cups. So let's replace, we will have a solution. I'll replace this with, I don't know if I can copy the cups. Can I? No, I can't. It's an image, but I can just draw the cups. So I'll just draw here 2 more cups instead. These squares are cups, right? So in the picture where I have now this 60, I have how many cups? 1, 2, 3, 4, 5 cups. And 5 cups are 60. Do you guys have the answer for how much is cup?
12.
Mm-hmm.
So the brewer is 24 because the brewer is twice the cup or the coffee maker.
Yep. 24. Because it's 2 12s, right? Perfect. Okay, thumbs up for this shortcut. Everybody understood what we did? Can I see
Yeah.
thumbs up on your screen?
Yeah.
Or just unmute, say yes? Carla,
Yes.
Dra.
Yes.
Okay, okay. Can we actually do the equations way somebody did or started doing, so we can, not always you can notice a shortcut. And here there was a shortcut. Sometimes there is no shortcut or it's not very convenient to notice it. So can I choose a kid who would like to help me set equations and we can solve it with equations? Yeah, who wants to go? Matvey, would you like? You have a thumbs up on your screen.
To help do the equation?
Yep, yeah. Let's solve it. We solved it with a logical trick, right?
Yeah, so
But now let's set up an equation as if we didn't find the logical trick. Okay. Let's talk about how to see this problem with just equations, and I'll switch the color so I can write. So the first condition here, the 60 and 2 coffee makers and 1 cup. How do you make an equation?
so it's gonna be like
Like 60 equals to what?
60 equals 2 same numbers plus 1 different number. So
Okay. Do you want to choose a variable for the 2 same numbers of the big 2 what? 2 times what variable, what letter would you use for the coffee maker?
I guess X.
Okay, 2x. So x is our coffee maker, okay, guys? X here, X here. And what letter would you like to use for the cup?
Y.
Okay. Yeah, these are the classical variables everybody uses for equations, a, b, x, y. Okay, so I have 2x and 1y equals 60. And then what do I have for the second equation? How about we choose another kid? Can I choose or somebody wants to volunteer? I see John. Okay, okay. Go ahead, whoever started talking.
Um and one x equal and 1x and 3y equals 60 as well.
Okay, x and 3y. And you see, I can drop the multiplication sign, just say 3y, 3 and y after equals 60. Thank you for writing, Nestor. Now, what I do with these, do you guys know operations with equations so that I can easier solve it?
Plus.
Let me put 60 here so it looks like 60. Okay, you gonna add them all?
Mhm.
Okay, then if we add it, let's try adding them. If you add two 60s on this side, I will have 120, and then I will have how many x's? That's I'm adding. 3 x's, and then I will have also how many y's?
4 Ys.
4 y's. It just creates another equations with two variables. The goal of my working with equations would be to try to eliminate one variable, to somehow do a subtraction or addition sometimes, so that there is only one variable left in numbers. So if I subtract in this way, if the equations are like this, I also will not get anywhere. So one way to eliminate a variable is take one equation and make same amount of some variable in both. So look at this equation. How many x's do I have?
1.
1. On the other one, I have 2. What if I had two x's as well here? What do I need to do to my second equation to have 2 x's instead of 1?
Multiply by 2.
Let's multiply everything by 2. Okay, so I say times 2 here. I put parentheses here and I say times 2. Now, let's see, I will have 60 times 2 is still 120. Then tell me what do I have on the other side?
2x and 6y.
And 6y. Okay, now you have same amount of x's, right? If somebody can circle, I have 2x here and I have 2x here.
You have to subtract 2x from 6y.
I cannot subtract 2x from 6y. I won't get an answer. They're different things. But I can, as a whole, the second equation is a big one, right? I can
Yes.
write the first equation right under 60 and then 2x and then another y on this side. And now, same as you added the equations before, I can do subtraction here. I can go row by row because the amounts are same on both sides. And I can subtract 120 minus 16, see what's left. How much is that?
60.
Okay, then I can subtract 2x minus 2x and see what's left.
0.
Nothing, and that makes me happy because no x's anymore. Thank you, Matvey. You're writing it on the other side. And then 6y minus y and see what's left.
5.
5y. So we get
5y.
this. We get 60 equals 5y, or if you divide 60 by 5, you'll get 12.
12.
And that's what we got for the cup, right? So y, which was the cup, if you remember, that was 12. Now you have all the 12s. And how do you figure out the x?
You can, so you have the 12 right here, and using that 12, we have 2 of these, with the remainder being 48, you can divide that by 2 to get the amount of coffee cups.
Right, right. So you basically, what you did, if we go back, we went back to the picture, right? We like pictures more, but this picture, the first equation is here. Let me use another color because it's becoming happier here with colors. So this green equation on the blackboard, we just figured out the y, so we can substitute its value. We figured it's 12. Now I have 2x and 12 making 60. So you subtract 12 from 60, you get 48. And if we go formally, 48 equals 2x. And then we divide by 2 and you get 24 as we had before. And yeah, Matvey, you can finish. Okay, thumbs up, everybody, for everything we did. Okay.
Can I go to the bathroom?
Yes, of course. Yeah, come back and catch up to what we're doing. So it's good to know different ways for each problem. Now, this was more math than just a warm-up for visual. So let's do a warm-up visual puzzle. How about that? In here. This is from IQ test. So it's a real problem that we took. Maybe we changed a little bit from one of those tests that check how well we can reason. They are called IQ, for measuring our power of the mind. So how about, don't yet circle it on the screen. Just give it a thought. It's not easy, not trivial. But here there is a connection somehow in how shapes were made. Look for patterns. Maybe going sideways, is there a pattern? Maybe going downwards, is there a pattern? And then this way you will figure out if there was a pattern downwards, this last sign would follow the same pattern. If the pattern was working with you sideways, then it's the same thing in these two rows, and that sign will be determined by the same rule. So I think this one needs some time to think. At least when I first tried it, I had to think some time. And talk it with your parents, talk it with yourself. What do you guys think? And when you have ready answers, text Ron. Ron, tell me when you have a lot of people who are thinking something.
And by the way, guys, I couldn't solve this one either. I had no idea what this was. Genuinely.
So you still
I
don't have
still
it?
haven't. I've looked at it for a while.
So
Still
you
have no
can't
idea.
solve it. Yeah, good. Okay. Anybody has ideas? Don't give us a full answer yet. Which direction are you thinking? And you think it may be working? What are you thinking how are you thinking to connect pictures, either in a row or in a column? We are looking for a connection. How first, second, and third pictures are connected. Anyone got something or not yet? Oh, Matvey, you're drawing. Oh, you're drawing the two pictures on the third one. Right, that's a clue. Wait, yeah. So I think it's a clue enough, actually. Wait, leave only what Matvey drew, because he has two colors. Okay, that may help people think. I'll erase this, and maybe I'll go over with.
Oh, I got it now.
Yeah.
Okay. Yeah, that makes sense.
Thank you, Matvey. Okay, let me try to highlight it, I think. So this part, right, is one color, and it's here. And then that part is another color, right? And it's this. So now you guys, can we check if this works in the second row? If I highlight in red the left side, and in green I highlight the right side. Can I ask whoever put the stars, just take them away for a second so we can see better? Okay. So, but then it's kind of weird. So the green, what are they doing? Are they overlapping two pictures in the middle? No. How does this work? Because I don't see an overlap of two sides. Matvey, what did you see? Or, oh, I have Ezra in Ezra rose the
This
hand.
one,
Okay. Yeah.
I just saw that they fit together,
Okay, just the first part. Ezra, what did you want to say?
but
Oh,
I was just gonna. So you see this one right here? It's like these two, but it's turned.
mm,
And
okay.
also this one.
Okay. They don't connect over the three. They do connect inside a line, like you noticed. Now, yes, Ezra.
If you add any of the two ones on the right and the left, they equal the one in the middle of those two.
So
Like,
I
and
don't.
if they overlap, you erase that one that overlaps, basically.
So I think it's not adding them, right? If you because I don't see. Let me choose a pen actually instead. So this green one. Let's do a fat pen. Yeah, this green one. Okay, I don't see it entirely here because entirely it would go like this, right?
Yeah, I think that the overlap, because on the other side of that green one, there's the same thing. So I think that if they overlap, you have to erase the one that overlaps.
Ah, so we do combine them first, right?
Yeah, and
We
you erase the overlapping ones.
But so if I draw the red one now, the one that overlaps, I need to erase, and that's what's gonna be left. So maybe we're thinking these two pictures, combine them, and in the resulting one, erase what overlaps, right?
Yeah.
I erase these two. I take the first and the second picture, I combine them. I erase the overlaps and I get the third.
Yes.
Does it make sense? Let's see if it works in the second row. I'll erase. So I take this one, I draw over here, and now I need to erase the overlapping part. Do I get this?
Yeah.
Okay, so now you guys can draw and erase the overlapping part. Which one of these do you get? We can draw it, right?
Yeah. You would get that one.
We only erase the overlapping part. So let's again clear. I'm gonna draw this and erase the overlapping part.
Yeah.
People the red.
So that is the one that I got, you see. And that's the one that I sent to Ron.
And I see Benjamin got the same, right? Do you guys agree? Everybody can see it. So it's not A, Yunus, because you draw the full square on top. Now you start erasing the overlapping parts. So I'll just erase them, these guys. I can't erase I need to erase in blue. So I need to erase these two, the overlapping parts. And what's left is the top and the angle. Whew. Okay, good. These
And
yes.
a little cool thing as well. This pattern not only works if you overlap these two and erase the overlapping lines, it also works in reverse. If you overlap these two, you get this shape. And if you overlap these two,
Which
you
one?
get this shape.
It doesn't work here on the bottom one.
Why not?
You overlap these two, the blue ones,
Uh-huh.
and you don't get the middle shape, right?
Wait a minute. Let's check that.
No, you overlap. We can
No, you get it.
really? Here
Look,
is the side one, and I put the X in.
this one gets deleted because it's overlapping.
You delete the overlap. Yeah. If you delete the
And
overlap,
then
it works.
right, that's what is in the pattern.
Yeah.
That's
You
what
need
we talked
to
about.
delete the overlap, then it doesn't matter which ones you combine. Yeah.
So, actually, another way to solve this problem would have been thinking about what in these two could you have put into here to create this one? Or what could have combined in these two to create this one?
I get it. You guys get it?
Yes.
So you just draw here something that overlap was erased, and then you would be left with a square. And that's your shape.
Mhm.
That's a cool way of thinking about it. Thank you, Ron. And thanks to everyone who thought and helped. And let's continue. Now let's go to real kangaroo problems. Let's see this one. So let's try it. Ron, do you want to read it for us? Your English is better than mine.
All right. Marcus's dining room table is usually 2 meters long. When his family has guests over, they use the leaves and make the table 3.5 meters long. Both leaves are the same length. What is the length of one leaf? And by the way, table leaves, not tree leaves, not tree leaves. They're these
Guys,
little extensions
these guys.
that you.
So I don't know if you had enough time to think about it because we just read it and then it kicked us out. So
Can I answer
maybe
it?
we can. I see Matvey and
Yeah.
Benjamin wanna talk. How about we do this trial? I'll give Matvey and Benjamin to talk about these problems. Can you guys talk to each other, kind of give hints and see how you
Yeah.
you figure it out?
So,
Talk to Benjamin. Like
What?
let's do a fun trial.
Okay, well, when we look at we first take 2 meters, which is how long the table is, the original table is. We subtract that from 3.5 meters because that'll leave us with how long two leaves are.
yeah, so I'll be 1.5.
Each.
Yep, 1.5 meters is both leaves. And then we divide 1.5 into two parts, which leaves us.
Benjamin, remember to leave space for your friend to talk with you. Okay, let's do this exercise. So 1.5.
Yeah. So you can do it like this.
So these two together are 1.5. Okay.
And
So
then, so a half.
you can think of 0.5 as 0.50, and then it's easy to divide it by 2. If you
Mm, I'll be
what's 50 divided by 2?
times.
yeah. So that will be about, so if we add this together, it will be 0.75.
0.75. And thank you for each one who is helping here. Okay, let's ask all other friends. Did you follow through this with this?
I'm just going to I need to write this down.
Okay. Yeah, I can keep it on the screen for a little bit. So it's more or less straightforward problem, right? It's the one that Kangaroo usually gives at the beginning of the test. It's just worth 3 points, which is not just. There are, I don't remember how many of these are in the test, but I think there's 10, 10, 10, because the test has 30 points total. And there's 10 of 3 points, 10 of 4 points, and 10 of 5 points. So 10 of 3 points is 30 points of your test. That's quite a lot, but these are usually just read carefully, sort through the information, and solve more or less straightforward. Okay, so everybody is good with this problem? With all the chaos of logging off and coming back? Thumbs up. Anybody has a question? Should we explain it? Okay, so
This one, it was easy.
yeah. That's what I said. At this point, we are going there in Kangaroo, since we're going over the test. there are 3 types of problems. There are 3 points, there are 4 points, and there are 5 points. And there is 10 of each in the test. So I want you guys to know there are easy problems and you shouldn't be scared of them, and they give a lot of points. So how about we maybe solve another easy problem, but it's visual. So
Yeah.
it's fun. Let's not.
I'm almost done writing mine down, so like just like 1 minute.
Oh, you have to run out afterwards.
Yeah, I
Okay.
don't know. I just want to.
Okay, well, you guys can stay as much as you can. I'll stay here because we lost some time with this logging in and logging out. How about this problem? Just text Ron in the chat, and after a while,
For some reason, when I open chat, I don't have Ron's chat.
you need to add it. Remember,
Is
I
Ron
last son.
is Ron appearing as EMC8 classes? Is that
Yes,
Ron?
yes.
Oh
you
no.
didn't
Oh
rename
no. I
it.
didn't change my name. That's too bad. Da-da-da.
And I didn't change my name either. It's our Zoom links. Here we go. Yeah, there we go.
And
Okay.
for me, it says chat disabled.
Ah,
The
sorry.
only person I can communicate with is you.
Me?
It won't let me communicate with anybody else.
Yeah, me too.
Okay, then text me. What's happening is we opened the new Zoom link and we didn't reset chat settings. Let me. Oh, Ron knows how to do it. Okay, while you guys are thinking, we are fixing the chat then.
Okay, I'm just gonna wait. Okay.
Tell me what I am. Yeah. Okay, meeting group chat. Yeah. Which? Okay, this one. Okay. Okay, now you should be able to choose and chat anyone, even your friends if you want. So, and Ron including. Now the chat is enabled. Thank you. Okay, we didn't read this one out loud. Everybody had a chance to read and try. Maybe someone can tell us what can you say in your own words, not solution, just the problem. What are we looking for? And let's look for a new kid who maybe read, understood it, and can tell us.
So I just wanted to say that these two
Mm-hmm.
are these two.
Yeah, they're connected.
Same for here.
Yeah, these corners are the same. They're connected, yes.
Say, and also some
A good observation.
in this one. Wait, no, this one right here. I'm pretty sure that one's this, not the other one, because when you fold it, those two would be touching. So and this would be touching, same thing with these, because those all touch at the very end. But these,
Change the picture. So like this.
yeah,
Can we just clear it for?
Yeah,
let me just clear the entire screen.
clear everything.
Yeah, so
This touch,
yeah, these,
this touch.
this, and this.
Those don't touch. Those don't touch.
Yeah, well, erase. These don't touch. So the question is these two. Okay, here someone else is still coming in. This does touch, but where?
that touches this guy. Because when you fold it, when these two touch, and you that's like the top flap of the box. So and because this panel right here is one side, same thing with the other these two. So this ends up being the top, and this one is the other is the last remaining side. This is the middle one's the bottom, and that one is the top. When you
Right.
fold it all up.
Bottom and this is top. So how about I'll erase and I'll just color the touching, and you guys can help me, the touching corners with the same color. So then we can see. So these two are blue. And then we'll change colors. This, okay, Matvey, you can do your blue. I'll do these two with green.
Wait, oh, so this is,
And I guess this is a green as well.
wait,
It is.
Yeah.
Well, how about we just clear the
That's
screen and
blue
have
there.
one person do it? How about we clear the
Yeah,
screen
yeah.
and
It's
just let
okay.
her
It's
do it?
almost done. It's almost done. I'm gonna drag Matvey's blue over. Oh, no.
That's-
Okay. I was trying to get it all together. No, it doesn't.
yeah, it's kind of just scribbles, so it's gonna
Yeah.
be.
Just do your other corner in blue there. And then these two are gonna be dark green. No. If I find. That's it. We don't need to put the lines. Now they're different color. There's gonna be pink. There.
Yeah.
Okay.
I mean, lines can help, but yeah.
So what's the shortest distance possible? Every one side is 1 centimeter. Let's see what people found. Ron, do you have answers in the chat already? Wait till
A couple, yes.
couple. Are they same or are they different?
It looks like C. Somebody not C, but looks like C.
Okay, so what are the options that you have in the chat? Some chose C. What else?
C, D, and A.
C, D, and O. We have
I
few.
think the people who chose D and A didn't quite fold the cube in their mind.
Okay, how about we maybe go over the solution, right? So we need what? To walk less around the cube, right? And visit each vertex. I'm not sure even if we want to go and do it on the unfolded version or in the cube, the 3D version. Just
I see how to do it. I see how to do it.
okay, Benjamin, give it a second. I want to ask other participants. You and Matvey already talked. If there's somebody else who wants to talk, I see. I forgot your name, but your mom's name is Tamara.
Tigran.
So, what's your name again?
Tigran.
Tiger?
Tigran.
Tigrin. Okay, Tigrin. Okay, so talk to us, please.
I think it's D
Okay.
because when you walk around the die, you go there, like on the real die, you walk walk 4 times around the top.
Okay, so you are suggesting to go around the top. I'll choose another color and I'll label the steps. And I see Ezra is doing the same picture, right? So I'll label, I need bigger one. So we go around the top, you suggest, right, Tigrin?
Yes.
1, 2, 3, 4 steps around the top. And right now you ended here in the corner you started, right? Everybody agrees?
That leaves us 9 though. If you
Okay, Ezra has another version. Ezra, wait, we will probably, if it's something that's not working, we'll get stuck. So I want to get to those places where we'll get stuck, or maybe we just have another way. So what do you do afterwards, Tigrin?
After
Where do you go? So we just did this. 1, 2, 3. We walked around the top. Then what?
then I go down
Go down. That's 4. 1, 2, 3, 4. That's 5. Okay. Then what?
Then to the right.
6. Then what?
Then up.
7. Okay. Then
Wait. Didn't we already the 7? Didn't we already go to this vertex right here?
yes, we did.
So that's kind of like a useless.
We'll have to repeat, and that way we'll probably use more steps.
Can I
Wait, there's
explain how I
another
can get
way.
7?
Who was it, Josh? Who said, can I? No.
Me, that was me, Benjamin. Can I explain how to do a 7
I
over?
want to give a little bit other kids as well to see, but the kid, do you want to draw yours? Do you want to draw? I can make another cube like this for you guys.
I can draw it. No,
You can draw it here. Just add some lines,
easy.
and you guys have squares. So who didn't speak and sees another solution? I think we're gonna get stuck here because we'll have to repeat the vertices. So I'll just go back on these guys. Do you have volunteers? Or I can ask somebody who, okay, Ezra, you go ahead.
So let's say you start at this one right
What
here.
are you drawing? Are you drawing on your own or on mine?
Yours.
So go
So
on
let's
the pink. Go on the pink one. Just let's use like a blue color.
Okay, so
Somebody else is using. Choose
I'll
the
find
flat blue color.
I'll use red.
Okay.
So let's say you start right over here, and then you go up to the left, down, over here,
In a second,
over
my
here,
I will.
over here, and then over there. It's 7. 1.
So you start here. You go up 1. Let's go like this. Then where do you go?
Over here.
2 here, right?
Yeah.
Okay.
then
3
here.
down.
And
then
then
4 behind, right?
yeah.
And
And then up.
Up. 5. Okay.
This way.
Forward 6.
And then down.
Down 7.
That's it. That hit all of the points.
So 1, up, 2, 3, 4, 5, 6, 7. Do you guys agree?
Yeah.
Yes.
That's what I was going to say.
Yeah.
So just 7.
So I was going to say too.
Yeah.
You can do it really easily.
Yeah.
It's a little roundabout though.
Yes.
You might get dizzy.
It seems like you can do it really easily, but we had those other versions as well, and it means that it doesn't obviously stick to everyone right away, which is good because this is our good practice. So, alrighty. Oh, you're drawing just this sticky thingy.
Yeah, it's weird.
Was there a way without drawing and tracing to do this? I'm not sure. I'm just actually asking right now.
I mean, if you have,
Hypothetical question.
I mean,
How
I'm pretty sure you can.
I'm
Let me grab my draw tool.
Without drawing, some reasoning, some words, just that will say it's 7.
You
Why?
can picture in your mind the cube and then draw it.
That's
Same
kind
problem.
of similar. Picture in the mind.
Yeah.
How many nodes did we visit? How many nodes does a cube have?
It has 6. It has 6 vertices.
6 vertices.
I think 6. On the top of the cube, you have 4. How many on the bottom?
Oh, the corners.
Vertices are corners. Yeah. How many
Oh yeah.
do we have?
There are 8 of them.
8.
Yeah.
8.
Can't we just
Yeah, there are
imagine vertices like this? So there's a vertex right here, vertex right here.
Mhm.
These two are the same vertices, so connect them. These two have a vertice. What else?
Lester is drawing on the picture.
This has a vertice. this has a vertice, this has a vertice, and this has a vertice, this has a vertice, like that.
I think I wouldn't try to imagine on the open net, and I don't want to draw, but I want to just think. I have 8 points of connections for my lines, right? Here I'm drawing 4 points. Okay, these 4 lines are 4 points of connection. If I'm going from one point to another, if it's possible to go from one to another, I will be doing how many steps? 1, 2, 3, right? Without repeating and going through each vertex. So I had originally not 4, I had 8. And I was able to go from one to another, and close it. Without repeating. So it's this line that we created, right? After we saw the solution, let me clear everything. The line was broken line that goes something like this in the space, but it's something you can open again. And it has 7 parts between 8 vertices. Maybe. Does it make sense? Am I making a mistake?
Yeah. Pretty much.
Yeah. So, because I know I'm not going to come back to any one of them, right?
Yeah, because for
I'm going to
this
have
we need,
some type of a road going from one vertex to another, to another, to another, to another.
and one road that connects 2 vertices immediately in one.
Yeah.
7.
And then you get 7 intervals between 8 points of the road without trying to draw. But good imagination exercise in this one. Okay, let's go and solve one more problem if you guys are ready. So it's it's a visual, but not as easy. Let's go to how about it's this one. Okay. So I'll read it quickly. You can use any triangle of your choice to cover a portion of a trapezoid below this one. Guys, can I ask you not to annotate when the screen, when we are reading especially, because it kind of takes away our attention, mine at least. So the overlapping points of the shapes will be cut away. Portions, sorry. Which of the following polygons is not possible shape for the pattern that remains? So this is more spatial and geometry reasoning type of thing. Do we all understand what they want me to do?
I have a question.
Yes.
Wait, so pretend I use this side and I put it like here. And it ends up looking something like this. Does that mean like what the red this part right here? The rest of it will get cut off? Like that?
No, the part that you put a triangle on gets cut off.
Yeah, the overlapping. So let's say if you add a triangle right here and then you add a triangle right here, this part will be cut off.
Except you can only use one triangle.
No,
Yeah.
you can use
The triangle can be any shape, but
You only use one triangle.
Not necessarily this triangle, guys. Let's read it carefully. So use any triangle of your choice. So you can, here, Nestor just drew one triangle. And then you can have this triangle replaced again, for instance, or that green one, or this. Now, how about let me draw a couple of options so we can make sure we understand how it can be. So actually keep your triangles, don't touch the screen. Okay. So right now we have plenty of triangles. I see an overlapping part, I will cut out. I see an overlapping part here, I will cut it out. I see an overlapping part here, I will cut it out. I see an overlapping part here, I will cut it out. Right? So maybe I'll use a white color to cut out all these things and a big pen. Now we need to think which of the following polygons is not possible. So let's just, with our trial, this was overlapping. Wait, don't color anything. Keep your triangles, please. Cutting out the overlapping part. You guys,
So pentagon is possible, so we can cross that out.
pentagon is possible. Okay. How do you see it? How about we draw what's possible?
I can show you. Like, look,
Okay,
just
okay.
do that. Because the rest is also trapezoid. It's just that we cut a sliver of it off. So pentagon's possible.
So I need to overlap two triangles so that pentagon is left.
A pentagon.
Right?
A pentagon.
Wait, don't erase things so we can still see it, please. Don't use white color. Yes? So who was talking? About the pentagon. How is the pentagon possible?
Can I show, please?
It just
I
is.
see how the thing.
Okay,
I see how
let's
the.
choose one person. Who was it? Can I show? Say your name.
Nestor?
Yes, Nestor. Okay, go ahead, please.
We have one triangle like this,
Mm-hmm.
and then we have another triangle like, wait, like
You need another triangle that will overlap. You erase the overlap and then, okay, now.
this. And, oh wait,
Oh wait.
Like,
So
and then you need another triangle like this. Here.
Hold on.
so a pentagon can be any shape that like
Has five.
Five.
the
Hold on.
yeah, that's
Oh,
kinda
sorry. I flipped.
yeah. So a pentagon can basically be any shape that has 5 sides.
Mm-hmm.
I think everybody does that. It doesn't have to be sort of like this kind of pentagon.
Yeah, you guys can use straight lines if you want to build shapes. So here is something that has 5 sides. You mean like this, right?
Yeah, all the way across.
Heptagon, heptagon. As long as it's connected and has 5 sides, octagon, all these
Like
are
this.
Wait,
considered.
I accidentally drew a hexagon, but a pentagon is possible only if you extend it all the way to the corner. But I accidentally just drew a hexagon because of this remaining part here. So I know that pentagon and hexagon are possible.
That makes me think about the last answer.
Yeah, it does.
Maybe every shape is possible if you overlap triangles.
Oh
Some
yeah, we can. Wait. We can
Wait.
get. Wait, let me try something. We
how
can get
about
any
you guys,
shape possible from
how
this,
about I
right?
make some more trapezoids and you can make trials on the screen. So
then
what you
yeah,
can do is draw your own trapezoids. Here you go.
I'm in an octagon. I made an octagon. Eunice, can you please stop drawing on the? I literally just figured.
So here's some more
Okay, I'm using
for you
this one.
to use.
Wait, guys. I think you're misunderstanding the problem. You're supposed to draw one triangle on the pentagon and remove that part of the triangle from the pentagon, and then you get what's left of the pentagon. You don't draw two triangles.
You mean, oh, we probably are misunderstanding. Let's read it again.
What I
Can we clear it?
I think
Just
for example,
Any triangle of your choice.
So like if I were to draw like this triangle part would be cut out.
yeah, that triangle part would be cut out. You don't draw two triangles you don't draw two triangles because then what's the trapezoid for?
Yes, then it becomes crazy. So thank you, whoever caught our mistake. So it doesn't say use one triangle, but that's what they probably mean. Use any triangle, but only once. Then the overlapping portions of these two shapes, the triangle and your original trapezoid, will be cut away.
Yeah.
So here is one triangle, you cut away and you get how many sides of the shape?
5.
In what's left here is
Oh,
the
hexagon.
shape. Let me make it fat. 1, 2. Oh, 1, 2.
That's why I figured out the one you're doing right now. That's
5,
Oh, yeah.
6,
7.
7. So this is a heptagon.
Yep.
I think octagon is not possible.
So heptagon is, we just did.
No, octagon.
Octagon,
I said that
octagon.
wrong. I said
Eight
that wrong.
side is not possible. So we have here a picture.
Wait a minute, that's an
Let's
octagon.
check this one. This one is 1, 2, 3, 4,
No, I'm
5,
pretty sure the entire
7, 8. Octagon is possible. Here is the green one under somebody.
Yeah, we can put
Wait.
it out of bounds, I'm
Yeah,
pretty
I
sure.
made that.
Wait,
Mm.
we're allowed to like not the entire triangle has to be sitting on the on the thing.
No,
Yeah.
you
Oh.
cover portion of the trapezoid.
So it can be something like this, like just sticky.
Somebody did pentagon just now. Okay.
No, I think it has to be on the because it has to be a portion of the trapezoid, not
Yeah.
a portion of the triangle.
A portion of a trapezoid, correct. Yeah. So
Yeah. So it would be on the trapezoid. Let me try it.
yeah, but not the whole triangle has to be on the trapezoid. So these choices are correct.
Not the whole
But how do we get the
Yes.
hexagon? The one
Like
that
this, like this. I made one right here.
Where is it, Janusz?
Inside of my triangle, I made a big triangle. Inside of there's a hexagon with a triangle and a triangle like this.
1, 2, 3, 4, 5. That's a pentagon. Or is it an hexagon?
Wait, what? Oh no.
That's a pentagon.
It's only on
Pentagon.
this side, like that. So this thing is still a side.
3, 4, 5, 6. That's correct. In that little one on the left corner. Yeah,
Yeah.
so we were able to find ways to create all of them. So the last answer is correct for the right reason now. Okay. And I think it leaves us with, do we have, what time is it now? 12 to 1:15. I think let's play a little brain break or we didn't do a 5-point question. How about I give you a choice? Should we go and solve a harder 5-point question or a brain break and we wrap it up today? This took
Brain break, my brain hurts.
Brain break, wrap it up.
Brain break.
Okay, brain break. So something fun.
Brain break, wrap it up.
Because this is
We've
annoying.
been here for a long time. So
My masterpiece. I was
give me a
completing the
second.
triangle with my
I
wife.
have a nice brain break. Do you guys know how to solve what are they called? Hey, stop coloring on the screen, please. Do you know how to solve what are they called? Rebuses.
What?
So these pictures, each sticker has a secret message written. The way you read this secret message, it's usually word or couple. Oh, Ezra knows something. Ezra, so how about you show us with one of them? Which sticker are you gonna do? The yellow, the orange?
I'm gonna do the blue one. The blue one, the word sister is little, so that one's little sister.
Correct. See?
Big bad wolf.
Big bad wolf, big bad wolf.
Big bad wolf, that's correct.
Top secret. Top
secret.
secret.
Top secret.
Top secret, because we have a lot of secrets, but the point is arrow is saying top secret. And then
Around the world.
Around the
is
world.
it around the world? It is something around the world because you have the word and then around. But what is written around?
TR.
Around the world.
Trip
A trip around the world. A trip around the world. Trip.
Trip around the world. Yes.